Let's find a polar representation for the complex number z. Okay, remember a complex number is a number written in the form a plus bi, where a and b are real numbers, and I is the imaginary number I. Okay, so from this I know that a is 5, and b is this term right here, everything except for the I. That's a common mistake, is to leave the I attached. We don't want to do that. Okay, it's just a number. Okay, so now let's find the magnitude. Remember, the magnitude can be found by finding the square root of a squared plus b squared. Remember, a is equal to the magnitude of z cosine of theta. B is equal to the magnitude of z sine theta. Okay, just those are our three formulas here. So let's find the magnitude of z first. A squared plus b squared. Okay, 5 squared is 25. This other one is tricky here. 5 squared is 25, but the square root of 3 squared is 3. Okay, so that's how you would work that out. You would actually square each of those individually. And 25 times 3 is 75. Okay, so that's the square root of 25 plus 75. Of course, that's the square root of 100. That's just 10. So the magnitude of z is 10. Okay, let's note what quadrant this point would be located in. That's positive and positive. So that's going to be quadrant 1. Okay, positive and positive is quadrant 1. So let's use one of these formulas. I'm going to use a because that one looks easier. A is equal to the magnitude of z cosine of theta. I know that a is 5 and the magnitude of z is 10. Divide both sides by 10. 5 over 10 is 1/2. Okay, so now the question has become quadrant 1, cosine is 1/2 in quadrant 1 at pi over 3. Okay, so there we go. I have the magnitude, I have theta, so now I can write out this number, z, as 10 cosine I sine pi over 3.